users familiar with analysis like this may have been surprised by the mesh that was created by the solver, noticing that it is only a mesh of elements along the surface. The reason for that is that the default solver is a boundary element solver. That means that what the solver is doing is solving for the distribution of free charge on the electrodes in order to satisfy the boundary value problem. If dielectrics are present, it finds the distribution of bound charge on the dielectric surface. Other solvers are available, including what to many people is the much more familiar solver, the finite element solver. So if we solve with the finite elements, you will see a very different type of mesh being created. With finite elements, an artificial boundary is put around the problem, and a mesh of triangles is used to fill up the space. As with the boundary elements, the mesh is adapted to put smaller triangles where they are most needed. When you make a plot with finite elements, you will notice that the plot is coarse on the scale of the size of the elements that are created. So if we click on New Graph here and choose to make a plot of the electric field along this segment, you will see that there is wiggle in the plot here, which is associated roughly with the size of the elements in the vicinity. One of the advantages of the boundary element solver is that the field is computed everywhere by integration from the surface, and that means this coarseness in the results does not exist. So if we resolve this problem with a boundary element solver instead, then we generate the same plot. When you zoom in on this plot, you will see that it is completely smooth. So the boundary element solver is used as the default by ELECTRO because it tends to be the fastest way to the best solution. But there are many solver options available, including hybridization of the boundary elements and finite elements, so that the user is always able to make choices about how to solve, and especially is able to have independent verification available. Because these solvers work by different methods, if you get agreement between the two solvers, then you are quite confident that you have the right answer.